Steel plates are delivered to the plant. Plates are inspected. Steel plates having passed initial inspection are fed onto the manufacturing line for further processing. Plate ultrasonic inspection. Use the multi-channel automated digital ultrasonic flaw detection equipment to swing scan steel plates to detect any potential flaws such as lamination or possible slag inclusion. The process utilizes a special double crystal probe for detection of any defects which could potentially exist in the steel plate. Plate edge trimming. Trim the two edges of the plates to meet required specifications for width, edge milling, and desired groove shape. Plate edge crimping. Crimp the edge milled steel plate from both sides simultaneously till the curvature radius approaches the radius of the finished pipe. Pipe forming. Bend and form the crimped steel plate with 6 cylinders, 5200 kN pressure forming machine into the open pipe area. Tack welding. Close and tack weld the open pipe area continuously until it forms a closed round pipe seam. Inside welding. Weld the inside longitudinal seam of the tack welded pipe with welding head fixed so as to effectively control the welding quality, as well as record the store welding measurements. Outside welding. Weld the outside longitudinal seam of the inside welded pipe with welding head fixed so as to effectively control the welding quality and record the store welding measurements. Ultrasonic inspection before hydrostatic testing. Use the ultrasonic technology to test and detect any potential defects along the entire welded seam. X-ray industrial TV inspection before hydrostatic testing. Shoot the real-time X-ray image of the entire welded seam to detect any flaws. Mechanical expansion. Expand, straighten, and round out the pipe on the full-length basis to improve the strength, precision, and internal stress distribution of the steel pipe. Pipe head leveled off. Level up both ends by flame cutting. Inside-outside welded seam buffing. Buffs the inside-outside welded seam at the pipe ends with the pipe fixed and moving the grading head. Hydrostatic testing. Seal both pipe ends and then inject high-pressure water into the pipe to test the static hydraulic pressure on steel pipe. Record and print out the testing results for further examination. Phase array ultrasonic inspection. After hydrostatic testing, test the welded seam. Any heat-affected zones at the pipe ends with a phased array ultrasonic inspection system, which will locate and identify the size and shape of any potential flaws. The process is fully automated and provides for both linear scanning and sector scanning of the entire welded seam to ensure fast and accurate measurements and reliable flaw detection. Industrial X-ray television inspection after hydrostatic testing. Shoot the real-time X-ray image of the welding seam to detect any potential flaws. X-ray inspection after hydrostatic testing. Pipe finishing. Coat finish the completed pipe to ensure the dimensions are straight and round. Pipe end chamfering. Rotate the steel pipe fixed at the clamping system and chamfer the pipe ends to achieve required groove and edge specifications. Magnetic particle inspection. Test the groove surface at both ends of the pipe to detect any surface cracks or pipe defects. Auto weigh-in and measuring. Weigh and measure the pipe automatically. Auto store and print out and review the data. Pipe shape, size or parameters and appearance inspection. Inside-outside marking. Mark on the surface of the steel pipe as per product specification and customer requirements. The steel plates are coded and tracked through the barcodes under the SCADA system upon their arrival at the plant, and until the finished pipes are delivered to the warehouse, keeps an electronic file for each steel pipe it has manufactured, combining its steel plates data and inspection results for future use. LSAW system. LSAW, Supervisory Control and Data Acquisition, is utilized to collect technical and quality data for each major production process, and physical and chemical testing and online testing results. It also monitors the real-time operation status of each machine, controls the technical parameters, diagnoses any manufacturing problems, and this helps to ensure the proper operation of the plant. MES, Manufacturing Execution System. Office Automation (OA) System. The network application utilizes office automation, computer process data management, and remote access support to improve work efficiency, reduce operating costs, and enhance product competitiveness. Real-time video system. The system is designed to monitor the real-time operation of the plant. With special attention to the major equipment, customers can observe the production process online with proper authorization.